Hello, so today we're looking at transformations of graphs of functions. Okay, so let's see what questions are being asked. For the following quadratics, list the transformations. Okay, so this is good. They're telling us that we have quadratics. So that means we know what our parent function is. That means our parent function is y equals x squared. So now we need to look at each of the functions we're given and see how our given function is a modification of our parent function y equals x squared or a transformation of y equals x squared. We need to list those transformations. Okay, first one. Let's use blue. Y equals negative x squared. So what is our transformation? It's our negative in front of the x squared. And what does the negative do? It's a reflection in the x-axis. All right, so next one, part B, y equals a half times x squared. So again, the half is our transformation. What does it do? This is a compression vertically by a factor of 2, or a stretch of factor 1/2, or a stretch factor, scroll over a little bit, 1/2. Compression of the factor of 2 or a stretch of a factor 1/2. Next one, so C, y equals -3 times x minus 1 all squared. So we have a few transformations here. We have the negative, the 3, and this 1. Okay, so the negative reflection in x-axis. The 3 is a stretch, let's say a vertical stretch of factor 3. Stretch. Let's zoom out a little bit so we can see everything. We're in a vertical stretch of a factor of 3. And finally, that 1, that's actually a translation, right 1 unit. So translation, let's write it this way, a horizontal translation. Translation can be up and down, vertical or horizontal. So let's be more specific. Horizontal translation, right 1 unit. Oops. Unit. Good. So one thing we don't have here, which might be of some value, if you scroll over, we can write this in, is the general transformations on the function. So if we're given a function f, we have a few transformations that can be applied to f. So we have, this is probably the easiest way to look at it. Probably, but let's stick with this for now, because I think we're dealing with these types of transformations. So the A, so if we have a function f and we perform transformations on it, for example, A is a number, D is a number, and C is a number. So let's just make A, D, and C are real numbers. Then A is a vertical stretch. Vertical stretch. D is a horizontal translation. And C is a vertical translation. Now, depending on whether A is larger or smaller than 1, it's either a compression or an actual stretch. Depending on whether D is positive or negative, this translation is either left or right. And C, depending on whether C is positive or negative, this vertical translation is either up or down. So we're basically using this, this sort of pattern to determine what our translations are. So let's go back to part D. Next question, y equals 4x squared minus 1. Okay, so why don't we scroll over here? Okay, running out of space a little bit. Scroll over to the left. So this was part C. So for part D, let's look at it here. 4x minus 1. So we have two transformations. We have the 4 and this negative 1. So we have a vertical stretch of a factor of 4 and a vertical translation down 1 unit, and it's down because it's a negative, because we have a negative. All right, so part E, y equals negative 1/3 of x plus 2 all squared plus 4. Oh, interesting. Again, we have a few transformations. We have the negative, the 1/3, the 2, and the 4, the positive 2. Okay, so is that a positive or negative 2? So let's go back to our I guess our formula of sorts, or the pattern. So if you notice in our pattern, we have our function f, and our new transform function g equals a times f evaluated at x minus d plus c. So our d value is subtracted from x. So if we go back to our question in part E, we have y equals negative 1/3 x plus 2 squared plus 4. So if we rewrite this as, again, negative 1/3 x minus negative 2 squared plus 4. The negative 2 is is our translation left or right. Okay, so let's write out the transformations for this function. All right, so the negative is reflection. I'll scroll out here a little bit here to the right in x-axis. The 1/3 is a compression, vertical compression. I always forget that. Vertical compression. Of a factor of 3. The negative 2 is a horizontal translation to the left 2 units. Horizontal translation left 2 units. Okay, so great penmanship. And finally, the 4, that's a vertical translation up 4 units. Good. And one last question. F. Let's have a look. We have a 5, a 1, and a negative 2. So what are the transformations represented by those values? Let's scroll over to the left here and write them out. Okay. All right, so F So vertical stretch. Five. Vertical stretch of a factor of 5 by a factor of 5. Okay. Horizontal translation by 1 unit. By 1 unit to the right. Gotta get that direction in. And finally, vertical translation. Which direction down? 2 units. It's down because it's negative. It's to the right because this is actually minus positive 1. And the vertical stretch is by a factor of 5. Good. So that brings us to the end of our session. If you have any questions, please feel free to send us an email at info@raisebymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you again soon.